Welcome curious minds and sleepy thinkers. Settle into your softest place. Allow the day's hurried thoughts to drift away like tiny clouds on a slow wind. You've found a quiet cove where the questions are vast and the answers are not as important as the journey itself. Tonight, we're going to embark on a very special kind of journey, one that doesn't require us to move at all, but simply to open our minds to a possibility as old as the mountains and as mysterious as the deepest ocean trench. We're going to tiptoe into one of the most profound and humbling questions ever asked. What if, for a long time, we have been mistaken in our belief that humanity is the first and only intelligent species to have ever called this beautiful planet home? This isn't a race through a textbook or a high-speed chase for a single truth. It's more like a walk through an ancient silent forest where every rustle of the leaves and every ray of light filtering through the canopy invites us to see something familiar in a new way. Our universe is filled with mysteries, and one of the grandest mysteries might be hiding not in the distant stars, but right here beneath our feet in the silent geological archives of our own world. We'll explore the idea that before our cities were built and our stories were written, another chapter of Earth's history unfolded, a chapter of advanced life that rose, flourished, and then simply vanished, leaving behind only the faintest of whispers for us to find. The idea itself has a beautiful, elegant name, the Silurian Hypothesis. It's a name that sounds both scientific and mythological, like a star chart for a forgotten age. It was introduced by two scientists, an astrophysicist named Adam Frank and a planetary scientist named Gavin Schmidt, not as a statement of fact, but as a thought experiment, a way to stretch our imagination and challenge our assumptions. They wondered if an advanced civilization existed on Earth millions of years ago, say in the time of the dinosaurs, or even 100 million years after their demise, would we be able to find any trace of it today? Could nature itself, with its relentless cycles of erosion plate tectonics and burial, have wiped the slate so clean that we never even knew a game had been played? This line of questioning is so different from the way we usually think about history. Traditional archaeology is a story we can hold in our hands, a puzzle with clear, if sometimes dusty pieces. It's about finding pottery shards, crumbling walls, and ancient tools that were left behind by our direct ancestors. It's about a timeline that stretches back a few thousand years, maybe 10,000 years, to the first sparks of agriculture and the first city walls. It's a powerful and wonderful story of human ingenuity, and it's a story we know well. We can trace the lineage of our cultures, see the evolution of our tools, and feel a tangible connection to the people who came before us. But the Silurian Hypothesis asks us to look far beyond that comfortable timeline. It invites us to consider a story so old it's told in rock, not in words. It asks us to be detectives of a different kind, searching for clues that are not artifacts, but anomalies. Not monuments, but subtle shifts in the chemical makeup of our planet's very crust. It's the difference between studying a family photo album and trying to decipher the history of a great oak tree by reading the rings inside its trunk. We're not looking for the past we know, but for a past we've never even dared to imagine. It's a journey that requires a shift in perspective, a slow turning of our gaze from the relatively recent past to the almost incomprehensible vastness of deep time. Let's rest here for a moment with this idea. The world we see today, with its towering cities and intricate web of technology, has been built on a planet that is almost 4.5 billion years old. Our entire written history, the stories of emperors and empires, of great discoveries and terrible wars, is just a fraction of the last few thousand years. If we were to hold up the age of the Earth as a single year, the entire story of humanity, from the first stone tools to the invention of the internet, would take place in the last few minutes on New Year's Eve. And in that vast empty calendar before our time, countless chapters have been written, erased, and rewritten by the relentless hand of nature. The Silurian Hypothesis is a gentle whisper in that long silence. It's a question born not of a wild conspiracy, but of scientific humility. It reminds us that our story is just one small thread in a tapestry of geological time. And if we, in our short span on this planet, have created a technological society, what are the chances that in the millions of years that preceded us, another intelligent species, a non-human one, might have done the same? It's an idea that makes us feel small, not in a scary way, but in a way that is profoundly humbling and beautiful. It suggests that civilization might not be a rare miracle, unique to our species, but a natural, perhaps even cyclical phenomenon that can arise on Earth-like planets again and again. So as we drift into the depths of this topic, let's leave behind the need for definite answers and simply embrace the beauty of the unknown. We'll be looking at concepts from geology, chemistry, and paleontology, but we'll approach them not as dry facts, but as pieces of a grand cosmic poem. We'll use our imagination to turn complex scientific ideas into simple, beautiful metaphors. A quiet sea of thought where we can float without fear of being overwhelmed. We'll explore the idea that the greatest discoveries may not be found in ancient tombs, but in the subtle hidden clues that our planet has been holding on to for millions of years, waiting for the right moment and the right minds to come along and ask a different kind of question. Imagine the Earth as a deep, layered cake. Each layer of sediment and rock tells a story. We, as archaeologists, have been meticulously studying the very top layer, the icing on the cake, where our own history is found. We can see the sprinkles of pottery, the tiny figures of our ancestors, the beautiful and complex patterns of our own societies. It's a rich and delicious story, and we have dedicated ourselves to understanding every piece of it. But what if this isn't the only story the cake has to tell? What if, far down in the middle of the cake, 100 layers below, there's another layer with its own set of forgotten sprinkles and hidden patterns? What if our focus on the top has kept us from even considering the depths? The Silurian Hypothesis is that invitation to look deeper, to let our curiosity reach far beyond the familiar. It is not an attack on the integrity of our known history, but rather an expansion of it. A recognition that our species' story, as magnificent as it is, might be just one chapter in a much larger, more epic saga of life on Earth. And the search for this lost chapter is an adventure that requires a new kind of map, a map drawn with geological timelines instead of familiar coastlines. It's a search not for a lost city, but for a lost age. A search for something so profoundly old that it has become part of the very fabric of our world. This thought experiment challenges us to question our own sense of specialness. For so long we have stood at the pinnacle of our own story, believing ourselves to be the first and the only ones to reach this level of technological prowess. It is a powerful and comforting narrative. But what if our very presence is not a unique miracle, but a natural outcome of evolution on a planet that has hosted life for billions of years? What if the rise of intelligence is a kind of echo, a pattern that repeats itself when the conditions are just right? This idea doesn't diminish our importance. It puts it into a grander, more humbling perspective. It connects us not just to our human ancestors, but to a deeper, more mysterious rhythm of the Earth itself. So as we prepare to continue this quiet exploration, let's hold on to that feeling of wonder. The beauty of this thought is that it doesn't require us to dig in the dirt with a trowel, but simply to sit with the idea, to let it breathe in our minds, and to look at the world around us with new eyes. We'll move slowly, gently through the evidence, the challenges, the myths, and the new technologies that might one day allow us to see what has long been hidden. We'll acknowledge the vastness of the mysteries and honor the fact that not every question has an answer. We will celebrate the question itself as a thing of beauty. And as we do, we might find that the world we thought we knew becomes infinitely more interesting, more complex, and more full of silent, beautiful secrets than we ever imagined. The journey begins with a single question and a willingness to simply wonder, what would such a civilization leave behind? This question sits at the heart of our gentle inquiry. If an advanced society existed millions of years ago, what would their legacy be? they wouldn't leave behind the kind of artifacts we associate with our own history. We can't expect to find metal tools preserved for 100 million years, or the petrified remains of a skyscraper. Nature is too powerful, too relentless in its processes of decay and renewal. The mountains rise and fall, the oceans swell and recede, continents drift like great ships across the mantle. In the face of this immense power, even the strongest of human constructions are just temporary etchings in the sand. So if we are to look for them, we must search for something more subtle, more enduring, something that would be resistant to the immense pressures of geological time. We're not looking for a lost city, but for the ghostly imprint of a civilization's presence. Like the fossil of a leaf pressed into stone, we must seek out the impressions, the chemical residue, the indirect clues that a civilization once existed, even if all the physical evidence is gone. We must become forensic scientists for a planet. The kind of evidence we might find would not be a single dramatic artifact, but a pattern of anomalies, a series of whispers that when taken together begin to tell a coherent story. A story that is different from the one we thought we knew. This is the beauty of the Silurian Hypothesis. It doesn't ask us to abandon what we know, but to expand our search. It encourages us to re-examine what we've already found with a new lens, to ask new questions about old data. Perhaps a geological layer that was dismissed as a strange natural occurrence is in fact the chemical signature of an ancient industrial process. Perhaps a strange isotope ratio in an ancient rock sample once attributed to a volcanic event is the fingerprint of a long-lost energy system. It is a humble admission that our understanding of Earth's history is incomplete, and that the greatest discoveries may be found not by looking for something new, but by looking at something old in a new way. We will explore these possibilities in the quiet moments to come. We will dive into the details of the indirect evidence that might be waiting for us to find it. We will talk about the relentless forces of nature that both destroy and preserve, and we will ponder the silent lessons that ancient civilizations, whether human or not, might have for us today. The path we are on is not a path to a simple answer, but a path to a deeper appreciation for the mysteries that surround us. It's a journey that might make us feel a little bit more connected to our home, this beautiful ancient planet, and to all the stories that it has held and continues to hold in its quiet, rocky embrace. So let's take a deep, slow breath and get ready to drift a little deeper into this quiet, wonderful thought. Let's drift a little deeper now, leaving the sunlit shores of our familiar history behind. As we journey into the ocean of deep time, the first question that ripples through our quiet minds is this: if a civilization existed so long ago, what would be left? Our own human history is full of tangible things. The Great Pyramids, the terracotta army, the fragments of Roman aqueducts. These are the stones we can touch, the pieces of a puzzle we can physically assemble. But if we are looking for a civilization from, say, 50 million years ago, the rules of the game change entirely. The very idea of an artifact, as we know it, melts away. Imagine a beautiful sandcastle you built on a beach. It has tall towers, intricate walls, and a tiny detailed moat. It is in its way a monument to a moment in time. But what happens when the tide comes in? Slowly, gently, the waves lap at the base. Then, with more force, they sweep over the walls. In just a few hours, the sandcastle is no more than a memory, a ghost, beneath the water's surface. And after a day, even the sand itself has been rearranged and shifted. All that remains is the beach, a vast, flat expanse, with no hint that a small, beautiful city once stood there. Our planet's geological processes are like that tide, but on a timescale we can barely comprehend. The cities of a pre-human civilization would be the sandcastles. They would have crumbled, been buried, and been crushed under the immense weight of tectonic plates shifting and grinding against each other. Mountains would have risen where skyscrapers once stood, and deep ocean floors would have formed over what were once bustling marketplaces. The The relentless cycle of erosion driven by wind and water would have worn down every sharp edge, every deliberate carve, every constructed shape into the soft, unreadable blur of nature. Even the most durable materials we know, steel, concrete, plastic, would likely have been broken down into their base components, their molecular memory of being a thing completely erased. A plastic bottle would, over millions of years, slowly become a strange, unnatural-looking lump of hydrocarbons, its form and function lost forever. So we can't look for statues or ruins. That's a search doomed to fail before it even begins. Instead, our quiet exploration must turn to something more subtle, more resilient. We must search for the whispers, not the shouts. We need to look for the things that don't decay, the things that can be buried, heated, and compressed, and still retain a memory of their origin. We need to look for indirect evidence. And what might that indirect evidence be? The most promising avenue for this search is through the quiet language of chemistry. Every civilization, no matter how advanced, leaves behind a kind of chemical fingerprint. We leave a trail of isotopes, processed materials, and atmospheric shifts that in theory could be preserved in the geological record. Think of it this way: our modern industrial society, with its factories, cars, and power plants, is pumping an enormous amount of carbon and other elements into the atmosphere. This has a direct and measurable impact on the chemistry of our planet. These changes aren't just fleeting. They become part of the Earth's story, trapped in ancient ice, buried in deep-sea sediments, and locked away in the layers of rock. This is the central idea we'll contemplate now. What if a pre-human civilization did the same thing? What if their technology and industry left a mark so profound that it became a fossil? Not a biological one, but a chemical one. We're not looking for a lost city. We're looking for the chemical echo of a lost city. Scientists are now exploring what this echo might look like. One of the most intriguing clues would be an unusual and abrupt change in the ratios of certain isotopes. Isotopes are versions of chemical elements, and they are everywhere. We can think of them as different weights of the same building block. Nature creates these isotopes in a predictable, stable ratio. But industrial processes, like burning fossil fuels or nuclear fission, can dramatically alter these ratios, leaving behind a unique atomic fingerprint. Our own industrial civilization, for example, is leaving a distinct carbon isotope signature in the atmosphere, and this signature will be preserved in the rocks and sediments of the future. If a civilization 100 million years ago did something similar, we might find a layer in the geological record that shows a sudden unnatural spike or drop in a specific isotope, a tiny and silent scream of an industry long since forgotten. Imagine a slice of Earth's history, a geological core pulled from the deep ocean floor. It's a perfect timeline, a beautiful layered cake of rock and sediment. Each layer represents a different era. The top layers are from our time, the ones below are from the time of the dinosaurs, and so on. A geologist looks at this core and sees the natural expected patterns of change, the rise and fall of certain minerals, the traces of ancient life, the steady hum of a planet doing what it always does. But what if 50 million years deep in this core, a layer appears with a startlingly high concentration of, say, platinum or copper, a layer that doesn't match any known natural event? A layer that looks like the waste from a massive smelting operation, or a discarded byproduct of some technology we can't even imagine. It would be a chemical whisper from the past, a silent question mark in the middle of a predictable story. This isn't just about isotopes. It's also about unusual minerals and synthetic materials. Nature is a master builder, but it has its own set of rules. It creates minerals in predictable ways under specific conditions of heat, pressure, and chemical composition. An advanced civilization, however, creates new rules. They forge metals, create alloys, and engineer materials that would never form on their own. They might build things out of a substance we have yet to discover, a material designed for a purpose we can only guess at. Over the course of 50 million years, those materials might not remain intact. They would likely be broken down, their original form lost, but their chemical essence might remain a strange combination of elements locked away in the rock, a tiny, hard-to-explain piece of a larger puzzle. We can think of this as the difference between a natural piece of granite and a manufactured ceramic tile. A geologist looking at a rock formation from 100 million years ago would expect to find things like granite and sandstone. But what if they found a layer containing millions of tiny ceramic-like shards, or fragments of a fused glass-like substance that could only be created under extreme controlled heat? It would be a strange, unnatural-looking interruption in the steady, beautiful pattern of natural history. A clue that a civilization had once existed, even if only in the form of its melted, fragmented ghost. And what about the atmosphere? Every civilization that has used fire-burned fuel or created industrial processes has altered the chemical makeup of the air around them. Our own society has done this on a planetary scale. A pre-human civilization would have done the same. The chemical remnants of their atmospheric pollution would have been trapped in air bubbles in ancient ice cores, in the very structure of ancient rocks, and in the deep-sea sediments. Scientists could one day drill into an ice core from Antarctica, and at a depth corresponding to 50 million years ago, find a sudden spike of an industrial gas. It would be a gasp of air from a forgotten age, a silent chemical message from a world that is now long gone. The search for this indirect evidence is a beautiful testament to the power of science. It's not just about one discipline. It's a quiet conversation between many. Geology provides the timeline, the layers of the Earth that serve as our archive. Chemistry provides the language, the atomic fingerprints and isotopes that tell the story. And planetary science, the field that looks at the history of planets, provides the questions asking what a planet-wide technological civilization would look like and what kind of mark it would leave behind. They are all working together, gently pushing the boundaries of our knowledge, inviting us to consider a bigger, more complex picture of our planet's past. This is a search that requires immense patience and a willingness to accept that the clues might be subtle, almost invisible. We are looking for something that has been weathered, crushed, and recycled for millions of years. We are looking for a ghost. The evidence won't be a gleaming piece of metal, but a faint, unnatural pattern in the arrangement of atoms. It won't be a ruin, but an inexplicable mineral layer. It will be a story told in the quietest voice possible, a story that we can only hear if we listen with the most sensitive instruments and the most open minds. The beauty of this approach is that it is not dependent on finding a smoking gun in the form of a physical artifact. It is a search for a whisper that survived the roar of geological time. The evidence may already be in our labs, in rock cores we've already pulled from the ground, and ice cores we've already drilled from the poles. We may have already seen these chemical signatures and dismissed them as natural oddities or as glitches in our instruments. The Silurian Hypothesis gives us a new lens through which to view that data, a new question to ask of the silent ancient archives of our planet. It's a beautiful thought that the answer we're looking for might not be in a discovery yet to be made, but in a re-evaluation of the discoveries we've already made. And what of the nature of that lost civilization? Would they have been like us, with cities and roads and a thirst for progress? Or would they have been something entirely different, a society of beings we can't even imagine with technology that is alien to our very understanding? We can only speculate. But if they left behind the kinds of chemical fingerprints we've been contemplating, it suggests that they, like us, were a technological planet-altering species. They used energy, they processed materials, and in doing so, they left a mark on their world. The very act of finding such a mark would be a silent confirmation that civilization and all that comes with it is a pattern that can emerge more than once. So as we bring this part of our journey to a close, let's take a moment to sit with this idea. The idea that beneath our familiar story, there may be another one, a story told in the language of atoms and isotopes. a story that reminds us of the profound power of deep time and the quiet resilience of a chemical ghost. A story that turns the Earth itself into a time capsule, waiting for us to learn how to read its most subtle, most beautiful, and most secret language. Let's slow our minds once more and gently turn our attention to the great walls of silence that stand between us and that ancient past. As fascinating as the idea of chemical ghosts may be, this journey is not without its immense challenges. The greatest of these is a force so powerful it can erase mountains and swallow continents whole deep time. Imagine for a moment that you are a tiny seashell on a beach. To you, 100 years is an eternity. You might sit there for a single summer, or perhaps a few seasons before the waves and the shifting sands carry you away. Now try to imagine 1,000,000 years. 1,000,000 years is not a single summer. It is an almost incomprehensible chain of 100,000 summers and 100,000 winters. 1,000,000 years is the slow grinding passage of entire epochs. If an artifact from a pre-human civilization were to survive even that long, it would be a miracle. But we are talking about tens of millions of years, maybe even hundreds of millions of years. This is not a timescale we can easily picture. It's a timescale that breaks our minds. This immense passage of time is the first and greatest hurdle for the Silurian hypothesis. Over such a vast stretch, the planet itself is a relentless eraser. We are used to thinking of the Earth as a solid, unchanging place, but it is anything but. It is a dynamic living system, constantly being reborn and reshaped. The processes that drive this change are so slow and so powerful that they make a human lifetime feel like a single fleeting breath. Let's take a quiet look at some of these forces. First, there are the tectonic plates. The continents we live on are not fixed. They are enormous rafts of rock floating on a molten mantle. They drift, they collide, they pull apart. When two plates collide, one can be forced down into the Earth's mantle, a process called subduction. Imagine a technological civilization built on one of those plates. Over millions of years, its entire legacy, its cities, its buildings, its technologies could be slowly and inexorably dragged down into the Earth's fiery depths, melted and recycled back into magma. All the stories, all the scientific achievements, all the art would be gone, not just buried, but completely unmade. Even without the fiery end of subduction, the simple act of burial over millions of years would crush everything. Layers of sand, mud, and volcanic ash build up one on top of the other, each one adding immense weight. A city built on the surface could over 50 million years be buried under miles of rock. The pressure and heat from all that weight would be unimaginable. It would transform the very nature of the materials that made up that city, turning steel to rust and stone to powder, leaving behind only the most faint and distorted of impressions. And then there is erosion. Wind and water are the Earth's great sculptors. A single raindrop, a single gust of wind is nothing. But over millions of years, they can wear down entire mountain ranges to flat plains. They can carry away every trace of a built environment, leaving no sign that it was ever there. This is a quiet, gentle destruction, a slow but certain erasure. A civilization that thrived on a coastline or in a river valley would be especially vulnerable. The relentless action of the waves and the currents would slowly, surely grind its story to dust. All of these forces, subduction, burial, and erosion, combine to create a phenomenon that scientists call preservation bias. This means that certain types of evidence in certain types of environments are much more likely to survive than others. For example, a city built in a stable dry desert might fare better than one on an active coastline. A technological artifact buried by a volcanic eruption might be preserved for a time only to be crushed by the weight of a mountain range that rises millions of years later. The vast majority of a civilization's physical legacy would simply be gone, and only a tiny fleeting fraction might survive. And that fraction might not be representative of the whole story. We might find a single strange chemical signature, but have no way of knowing what kind of civilization created it, or what they were truly like. The silence of deep time is a formidable barrier. This brings us to the limits of our own scientific tools. We have become very good at dating things, at understanding the timeline of our planet. Methods like radiometric dating, which measure the slow decay of radioactive elements, are incredibly powerful. But even they have their limits, their own kind of uncertainty. The farther back we go in time, the more difficult it becomes to be precise. The Earth's geological record itself, the great archive we're trying to read, is incomplete. Over millions of years, much of it has been subducted, melted, or crumpled into unrecognizable forms. We are trying to read a book with many pages missing, and the pages that remain are often torn and faded. It's a beautiful challenge, but a profound one. Another challenge is the problem of interpretation. If we were to find an unusual layer in the geological record, a strange chemical fingerprint, or a weirdly patterned mineral, how would we know it was from a civilization and not just a rare natural occurrence? Nature itself is capable of creating things that seem strange and alien to us. The conditions deep within the Earth are so extreme and the processes so complex that some mineral formations might look remarkably like a melted technological artifact. A scientist might see this anomaly and, without a clear definitive piece of evidence to the contrary, rationally conclude that it was a natural phenomenon. This is a core part of the scientific process, being careful, being skeptical, and not jumping to conclusions. And in this case, the lack of a clear definitive link makes the hypothesis incredibly difficult to prove. The silence of deep time is a powerful teacher. It reminds us of our own impermanence and the fleeting nature of our presence here on Earth. It tells us that our story and the stories of all who came before us are subject to the same relentless forces. The cities we build, the technology we create, the art we cherish, all of it is just a temporary expression on a planet that has seen so many sunrises and so many sunsets. The Silurian Hypothesis doesn't promise us an easy answer. Instead, it invites us to contemplate the scale of our own ignorance. It asks us to be humble in the face of a timeline so vast it makes our entire existence seem like a single microscopic flicker of a candle. It is a thought that humbles us, not in a scary way, but in a way that is beautiful and true. It connects us to a larger, more ancient rhythm of the planet. It reminds us that we are part of a great unfolding story, and that the story may be far more complex and far more mysterious than we have ever dared to imagine. As we bring this quiet reflection to a close, let's take a moment to honor the great mystery of deep time itself. It is a silence that holds within it the secrets of our planet, the stories of forgotten oceans and ancient forests, and perhaps the story of a civilization that rose, and then with the slow, gentle, and relentless hand of time was simply erased. Let us now turn our gaze from the great destructive forces of time to the quieter, more deliberate work of science. Imagine a vast library, not of books, but of stone. Each layer of rock, each vein of mineral is a page. The pages are unwritten, holding only the silent record of their own formation. This is the Earth's great archive, and the gentle art of reading it belongs to geology. This ancient science is our best hope for uncovering the story of a civilization that might have existed 100 million years ago. For it is the only one that truly speaks the language of deep time. Geologists are the librarians of this archive. They don't just see a mountain. They see a story of uplift and erosion, of ancient seas and buried forests. They don't just see a riverbed. They see the slow, patient work of water over millennia, depositing sediments in layers like a series of photographs from a forgotten past. And their most powerful tool for reading this story is a form of scientific magic known as radiometric dating. Let's take a quiet moment to understand this idea. It is not as complex as it sounds. Think of it like a clock, but a very, very slow one. Inside certain minerals, there are radioactive elements. These elements are naturally unstable, and over time they slowly decay or transform into other, more stable elements. This decay happens at a perfectly predictable rate, a rhythm that never changes, a beat that has been consistent for billions of years. By measuring the ratio of the original element to the new stable one in a rock sample, scientists can calculate with astonishing accuracy how long it has been since that rock formed. It's like finding a burning candle and knowing exactly how fast it burns, being able to tell how long it's been lit. This cosmic clock is what allows geologists to build a timeline of our planet's history. It's how they know that the dinosaurs disappeared roughly 66 million years ago. It's how they can pinpoint the timing of volcanic eruptions, the shifting of magnetic poles, and the changing of global climates. It is the framework upon which all our knowledge of deep time is built. So how would this help us find a lost civilization? It is the same quiet, careful work of looking for anomalies. In the vast, sweeping narrative of Earth's history, as read by these geological clocks, there are expected patterns. We know what a natural geological event looks like: the sudden specific signature of a volcanic eruption, the slow steady accumulation of a floodplain, the distinct mineral content of an asteroid impact. These events leave behind a recognizable chemical and structural fingerprint. A volcanic eruption, for instance, leaves a layer of ash that can be dated with incredible precision. This ash layer becomes a benchmark, a point in time that can be found all over the world, allowing scientists to correlate events across continents. But what if buried deep within a layer of rock dated to 50 million years ago, a geologist finds something that simply doesn't fit? What if they discover an abrupt, massive disruption in ancient rock layers? Something that doesn't match a known volcanic event, an asteroid impact, or any other natural process? What if they find a layer of rock that has been heated to an unnatural degree in a way that suggests a powerful controlled process rather than the chaotic heat of a volcano? It would be a moment of profound mystery, a page in the stone library with a strange, unreadable symbol on it. This is where the interdisciplinary nature of the search comes into its own. A geologist might find this anomaly, but they would need to work with a chemist and a physicist to understand what it meant. A chemist could analyze the mineral content and isotope ratios in that strange layer, searching for the atomic fingerprints we discussed earlier. A physicist could use advanced tools to look for signs of extreme pressure or temperature that don't align with what is expected from nature. For example, imagine a team drilling a core sample from the deep ocean floor. This core is a pristine, undisturbed record of millions of years of Earth's history. They are looking at layers of sediment from 50 million years ago, a time known as the Eocene epoch. They expect to find the slow, steady march of biological life and geological processes. But what if they find a layer that contains a sudden, inexplicable concentration of rare Earth elements far beyond what could be explained by natural forces? These are elements that are essential for our modern electronics. A natural deposit of them would be gradual, a slow buildup over a long period. But a sudden spike, a thick layer that appears almost overnight in geological time, would be a stunning puzzle. Or consider a more subtle clue. Geologists use a technique called stratigraphy, which is the study of rock layers. These layers are like the pages of our book, stacked in chronological order. They look for continuity, for patterns that make sense. But what if in a layer from the Cretaceous period, a time when dinosaurs still roamed, they find a sudden massive disruption in the stratigraphy? An enormous localized area of rock that has been rearranged and mixed in a way that doesn't match a landslide or an earthquake. It could be a sign of massive earth-moving and engineering project on a planetary scale. It would be a beautiful and terrible question mark, a silent monument to a time we can barely fathom. The beauty of this search is that the evidence may already be in our hands. Scientists around the world have been pulling core samples from the deep ocean, from the polar ice caps, and from ancient rock formations for decades. They have amassed an incredible amount of data about our planet's past. The Silurian Hypothesis encourages us to go back and look at that data with a fresh perspective to ask new questions about the strange anomalous signals that have perhaps been dismissed as mere quirks of nature. It's an invitation to treat the silent ancient data as a detective would treat an old unsolved case, to look for new connections between clues that were once thought to be unrelated. This quiet, slow, and deliberate work of geology and the interdisciplinary effort it inspires is our best chance of hearing the silent whispers of a lost civilization. It is a humble acknowledgement that our story is not the only story, and that the beautiful, chaotic, and dynamic history of our planet may contain a chapter we never expected. It is a story told not in words, but in the language of atoms, rocks, and the slow, steady tick of a cosmic clock. Let us now focus our quiet attention on a specific moment in the deep past, a moment that stands out in the long, slow story of our planet as a sudden and dramatic event. It is a moment that, to the gentle whisper of the Silurian Hypothesis, might offer one of the most compelling clues of all. We are going to travel back to a time roughly 56 million years ago, a time known to geologists as the Paleocene-Eocene Thermal Maximum, or the PETM. But let's not get lost in the long formal name. Let's just think of it as a great warm pulse, a sudden fever that gripped the planet. Imagine the Earth as a living body. For millions of years, its temperature, its breath, its heartbeat, the great cycles of its climate were in a state of slow, steady rhythm. The planet was a warm tropical world, but the changes happened over vast, unhurried stretches of time. But then, for a brief flicker of a moment, on the geological clock, a sudden fever set in. The Earth's temperature rose by several degrees, and a massive amount of carbon was released into the atmosphere and the oceans. This happened with a speed that was shocking by geological standards. Not over millions of years, but in what might have been as little as a few thousand years, an eye blink in the life of a planet. This event is not a mystery in the sense that we don't know it happened. We can see its footprint clearly in the geological record. Scientists find it in deep-sea sediment cores all over the world, a distinct dark layer of clay that marks the time of the PETM. This layer is a silent, beautiful archive. It contains the fossilized remains of tiny marine creatures whose shells tell us about the chemistry of the ancient oceans. And within this layer, in this dark band of clay, we find the chemical fingerprint of the great carbon pulse. The specific clue is the ratio of carbon isotopes. Carbon, like other elements, comes in different weights. There's a common lighter version called carbon-12 and a rarer, heavier version called carbon-13. The ratio between these two in the atmosphere and the oceans is usually stable, a quiet balance maintained by the slow cycles of life and death, of breathing and decay. But at the beginning of the PETM, this ratio suddenly shifted. The geological record shows a massive, abrupt drop in the amount of carbon-13. This is a very specific kind of signature, a chemical whisper that tells us something with a lot of light or a lot of life that was very old was suddenly released into the atmosphere. The carbon had to come from a source that was rich in carbon-12 and depleted in carbon-13, a signature that we see today when we burn fossil fuels. For a long time, scientists have been trying to understand what natural event could have caused such a sudden and powerful release of carbon. The theories are many and varied, all of them grand in scale. Perhaps it was a massive volcanic eruption that released an ocean of greenhouse gases. Perhaps it was the release of ancient methane locked away in frozen ice crystals at the bottom of the sea, a kind of planetary burp that sent temperatures soaring. Perhaps it was a combination of these things, a slow building pressure that finally broke through. But what if, and let's hold this thought gently, what if it wasn't a natural event at all? What if this great warm pulse was not a fever of the Earth itself, but the feverish byproduct of a technological civilization? This is the core of the idea we're exploring. It's not a firm answer, but a beautiful and quiet question. Could the PETM, the mysterious carbon spike of 56 million years ago, be the geological echo of a non-human civilization that burned its own fossil fuels, or developed some other energy-intensive technology and altered its world in the process. Imagine a civilization not of humans, but of some other intelligent species evolving on Earth long before our time. They might have been creatures of the sea, or of the air, or something we can't even imagine. And in their own story, they reached a point of technological complexity. They built cities, they developed industries, and they harnessed the power of ancient stored energy just as we have done. And in their great age of industry, they released an enormous amount of carbon into the atmosphere, changing the planet's climate. This would have been a beautiful, tragic, and silent moment in our planet's history. And the only thing left of it today would be a tiny dark band of clay, a strange shift in a chemical ratio that a scientist might one day find in a rock core. A silent question mark that whispers across millions of years. The beauty of this thought is how it connects the immense sweep of planetary history with our own present moment. As we grapple with the immense challenges of our own climate crisis, and as we see the clear, distinct carbon fingerprint of our own civilization being laid down in the geological record of today, it's humbling to think that we might not be the first to do so. The PETM serves as a kind of mirror, a ghostly reflection of our own world, a warning from a forgotten past. It reminds us that technology and its consequences are not just a part of our story, but may be a part of a larger recurring planetary story. The cycle of a civilization's rise and the inevitable change it brings to its homeworld might be a pattern, a rhythm that the Earth has seen before. This idea is not meant to frighten us. On the contrary, it can be a source of profound wisdom. It encourages us to look at our own impact on the planet with a sense of perspective. Our actions, so significant to us in this fleeting moment, are just another layer in the great deep book of Earth. It invites us to consider our place in the cosmic timeline not as a beginning, but as a continuation of a story that is far grander and more mysterious than we ever knew. It encourages us to ask ourselves, as we read the faint carbon-stained pages of the PETM, what story we ourselves are writing in the geological record of today. What will the future geologists find when they pull up a core sample from our time? The search for a lost civilization's chemical fingerprint is not an easy one. The scientific community has not found any definitive proof that the PETM was caused by a technological civilization. The prevailing theories still point to natural events, and for good reason. It is the most parsimonious and logical explanation. But the Silurian hypothesis is not about finding an easy answer. It is about asking the right question. It's a way to stretch our minds, to test the limits of our assumptions, and to remind ourselves that the universe is probably much stranger and more wonderful than we can possibly imagine. The PETM, with its sudden mysterious carbon spike, is a perfect canvas for this kind of thinking. It's a moment in the deep past that has a strikingly familiar feel to it. It's a moment that asks us to wonder not just at the power of nature, but at the potential for life itself to change the world it inhabits. So let's take a deep breath and gently let go of the need for a firm conclusion. The PETM is a mystery. It is a beautiful, intriguing puzzle, and the Silurian hypothesis is just one way to look at that puzzle, one possible lens through which to view that dark band of clay and those strange carbon ratios. It's an idea that reminds us that our search for life, whether on other planets or in our own deep past, may require us to look not just for physical ruins, but for the chemical ghosts of a long-vanished world. This thought experiment also provides a powerful framework for thinking about astrobiology, the search for life elsewhere in the cosmos. When we look at a distant exoplanet, a planet orbiting a star many light years away, we can't see its cities or its people. We can only analyze the light that passes through its atmosphere, looking for chemical signatures that might suggest the presence of life. We look for oxygen, for methane, for other gases that are not in a natural chemical balance. The Silurian hypothesis gives us a new way to think about this. It suggests that if we find a planet with a geological history that shows a sudden profound shift in atmospheric chemistry, it might not just be a natural event. It might be a sign of a lost civilization, a civilization that rose, used up its resources, and then, for whatever reason, vanished, leaving only a chemical echo in the stars. The PM in this way is not just a part of Earth's past. It is a lesson for the future. It is a cautionary tale, a silent message whispered across a vast ocean of time. It tells us that the rise of a technological species can have a profound and lasting impact on its world. And it tells us that the universe may be full of such stories of civilizations that rose and fell their entire existence, recorded only in the faint chemical language of their home planets. This quiet reflection should fill us with a sense of awe, not fear. We are part of this grand story. We are a part of a lineage of life that stretches back billions of years. And our own story, our own impact on this world, is a new layer in that same beautiful layered cake. We are, in a sense, the great-grandchildren of the PETM, living on a planet that has healed from a great fever and is now perhaps facing a new one. The past is not a foreign country. It is our home, and it holds the quiet lessons we need to learn. So let's settle back into our soft places and simply appreciate the beauty of this thought. The idea of a lost civilization, of a chemical whisper from a forgotten age, is not a demand for a new truth. It is an invitation to a new kind of wonder, a deeper curiosity about the world we inhabit and the stories it holds in its silent, rocky heart. Let us now turn our gaze from the silent chemical whispers of geology to the more familiar, if still profoundly mysterious, world of ancient myths and grand enigmatic structures. For so long, we have treated these stories and monuments as relics of our own past, the products of early human imagination and ingenuity. But what if we were to look at them through the quiet, gentle lens of the Silurian Hypothesis? What if some of these legends are not mere flights of fancy, but faint echoes of a much older, forgotten time? Imagine the quiet night sky, a canvas for countless stars. We see the constellations, we tell their stories, and we believe they are a reflection of our own human history and mythology. But what if we were to imagine that the stories themselves are far older than the names we have given them? What if a forgotten species once looked up at those same stars and saw a different set of pictures? A different set of stories now lost to the vastness of time. The legends, we have the stories of gods descending from the heavens or of lost worlds sinking beneath the waves, might be the last garbled fragments of a narrative that once belonged to another. Let's begin with one of the most famous and persistent myths, the story of Atlantis. The philosopher Plato described it as a technologically advanced, powerful civilization that sank beneath the sea in a single day and night of catastrophic floods and earthquakes. For centuries, scholars have debated whether Atlantis was a real place, a cautionary tale, or a symbolic fable. The traditional view is that it is a myth, a piece of allegorical fiction designed to teach a lesson about hubris and the downfall of empires. But what if we were to take the story not as a literal account of a human civilization, but as a distant, distorted memory of something that actually happened to a non-human, technologically advanced society? A society that flourished, and then perhaps as a result of a massive geological or cosmic event, was simply swallowed by the sea, its memory surviving only in the whispered stories of later emerging human cultures. The myth in this light becomes a different kind of clue, a narrative fossil, a strange and powerful dream that our species has had for millennia. And what of the great physical questions left behind the monuments of stone that stand in silent defiance of our understanding? Consider Göbekli Tepe in modern-day Turkey. It is a site of monumental stone pillars intricately carved with animals and symbols, built more than 11,000 years ago. It predates agriculture and pottery. It was built by hunter-gatherers. Its very existence shatters our conventional timeline of civilization, which holds that people needed stable societies and farming to build such a grand structure. Göbekli Tepe appears in the archaeological record with no clear predecessor, no slow evolution from simple to complex. It feels like a story that begins in the middle. The traditional view is that this site forces us to rewrite the history of our own species, to see our ancestors as far more sophisticated than we had given them credit for. But the Silurian hypothesis offers another more profound interpretation. What if the knowledge to build something like Göbekli Tepe was not an invention, but an inheritance? What if the hunter-gatherers who built it found or were taught by something much older? A forgotten civilization that left behind not a blueprint, but a sudden unexplained leap in knowledge. This idea of a sudden leap in technology or knowledge, a discontinuity in the archaeological record, appears in other places too. The Nazca Lines in Peru are another beautiful and humbling mystery. These gigantic geoglyphs drawings carved into the desert floor are so large that they can only be fully appreciated from the air. They depict animals and geometric shapes with astonishing precision. The people of the Nazca culture who lived thousands of years ago did not have the technology for flight. So how did they create these monumental images with such perfect proportions and alignment? We are forced to either invent a complex system of ropes and grids that could have been used to create them from the ground, a theory that still doesn't fully explain the precision, or we must consider a new possibility. What if the Nazca people had access to a level of knowledge, perhaps even the very concept of aerial viewing, that they did not invent themselves? What if the Nazca Lines are not just a work of art, but a silent testament to a memory, a story handed down from a time when beings on this planet could see the world from above? And then there are the Egyptian pyramids and the incredible megalithic structures found in places like South America. The precision of their stonework, the sheer size of the blocks, and their perfect alignment with astronomical events still baffle modern engineers. We are told they were built with ropes and ramps and immense human labor. And while that is certainly a plausible explanation, it doesn't fully account for the precision of the cuts and the astronomical knowledge embedded within them. What if these structures are not just products of human ingenuity, but echoes of an older form of engineering, a forgotten wisdom passed down across millennia? The silence of the stones is not an empty one. It is a silence full of questions. The Silurian hypothesis is not about disproving these amazing feats of our ancestors. It is about adding a layer of complexity to their story. It suggests that the history of civilization on Earth might be like a great book with many chapters missing. We have only found the most recent chapters, the ones that begin with us. But what if the book itself is far older with pages that were torn out or simply forgotten? These myths and monuments in this light become not just proof of our own ingenuity, but a beautiful and quiet puzzle, a hint that the story of intelligence on Earth may be cyclical, a pattern that rises and falls with the great rhythms of the planet. This perspective is not meant to be a wild, unscientific claim. Rather, it is a way to challenge the preservation bias of our own thinking. We are so used to the idea of a linear, progressive history that any evidence that doesn't fit a sudden leap in technology, an impossibly precise monument, a myth of a lost world, is often classified as an anomaly or a mystery, and then filed away. The Silurian hypothesis encourages us to take those anomalies out of the file and to look at them together to see if they form a pattern. It is an invitation to see the blank spaces in our historical record not as empty, but as potentially full. The idea that the past may be far more complex and mysterious than we ever imagined is not a source of fear. It is a source of wonder. It reminds us of the profound privilege we have of being here now to be the ones asking these questions. It connects us to a deeper story, a story that is not just about our species, but about the very nature of existence on this beautiful ancient planet. We are the inheritors of this world, and we might also be the inheritors of a knowledge and a history that we have yet to truly understand. So as we settle into the silence, Let us hold on to the beauty of these ancient myths and the quiet power of these stone monuments. Let them be not just reminders of our own past, but silent, beautiful questions about a past that might be far, far older than we ever knew. Let them be a testament to the idea that the earth itself is a living museum, holding in its silent depths the stories of all who have come before. Let's now turn our gentle gaze toward a different kind of force, one that does not build, but rather erases and preserves in a single violent motion. We're talking about cataclysmic events, the great thunderous moments in the Earth's history that have the power to reshape the planet and its story in an instant. These are the moments that, to the quiet whisper of the Silurian Hypothesis, hold a profound and beautiful double meaning. They are both the greatest destroyers of a civilization's legacy and the most effective preservers of its most subtle traces. Imagine the Earth as a grand, delicate masterpiece and a cosmic event, a massive asteroid strike or a supervolcano eruption, as a great splash of paint that not only covers a large portion of the canvas, but also freezes the moment in time. What was once a thriving landscape, a network of cities, or a web of technology, is instantly obliterated. But in that instant of erasure, something new happens. The cataclysm acts as a kind of cosmic seal, a time capsule. It buries everything under a thick, impenetrable blanket of ash rock or debris, protecting whatever lies beneath from the slow, patient work of erosion and decay for millions of years. Let's look at one of the most famous of these events, the one that ended the age of the dinosaurs, the Chicxulub impact. Approximately 66 million years ago, a giant asteroid, a mountain from the sky, slammed into the Earth in what is now the Yucatan Peninsula. The impact was so powerful, it released energy equivalent to billions of atomic bombs. It triggered a planetary winter, immense tidal waves, and global fires. It was a cataclysm of unimaginable scale, and it brought an end to an entire epoch of life. For a paleontologist, this event is a clear line in the sand, a boundary between the Cretaceous and Paleogene periods. It is a moment of profound, terrible ending. But what if we were to view this event through the lens of our hypothesis? If a technological civilization existed just before that asteroid hit, the impact would have been the ultimate eraser. Their cities would have been vaporized, their technology shattered, and their entire society would have been plunged into a long permanent winter. No physical remnants of their world would likely survive near the impact site. However, the debris from that impact was spread all over the planet, creating a distinct geological layer, rich in a rare element called iridium that scientists can find all over the world. This layer is a perfect time marker, a global seal. If a civilization had existed just before the asteroid hit its traces, the subtle chemical fingerprints, the unusual isotopes, the strange tiny pieces of industrial material might have been buried and preserved, locked away beneath that blanket of iridium-rich dust for 66 million years. The impact in this view is not just an ending, it is also a beginning of a different kind of story. It is the moment that a civilization's chemical ghost was perfectly preserved, awaiting a future where we would have the tools to dig deep enough and to understand the meaning of that strange buried layer. It's a beautiful and humbling paradox. The very force that would have annihilated them is the same force that would preserve the silent, fragmented record of their existence. And what of the great geological events on Earth itself? Volcanic eruptions, especially those from supervolcanoes, can be just as powerful. The Toba supervolcano eruption, for example, which occurred about 74,000 years ago, released so much ash and sulfur into the atmosphere that it may have triggered a global volcanic winter and a population bottleneck for our own human ancestors. Such an event would have completely obliterated any civilization in its path. But in doing so, it would have created a layer of volcanic ash, or tephra, that acts as a perfect time capsule. This layer, like the iridium layer from the asteroid impact, can be traced across continents, giving us a precise geological moment. A city, buried under a thick blanket of volcanic ash. Its technological footprint, sealed away from the forces of erosion and biological decay, might be preserved in a way that nothing else could be. The heat and pressure might turn its buildings to a form of strange glassy slag, but the chemical and isotopic signatures would remain a silent monument to a time that has been forgotten. Finally, let us consider the slow rhythmic dance of the planet's great cycles, the cycles of ice ages and sea level change. Over millions of years, the Earth has breathed in and out with massive glaciers growing and receding. As they grew, they acted as great bulldozers grinding down landscapes, crushing and dragging everything in their path and erasing the surface record. But as they receded, they left behind immense deposits of glacial sediment, a kind of geological concrete that could protect whatever lay beneath from the slow work of erosion. The glaciers both destroy and preserve a powerful contradictory force, and in that great breathing of the planet, sea levels have risen and fallen by hundreds of feet. When the sea level was low during an ice age, ancient coastlines with all their cities and settlements were exposed. When the ice melted, the seas rose again, swallowing those lands whole, preserving them in the cold, calm depths of the ocean. A civilization that thrived on a coastline millions of years ago might now lie perfectly preserved, buried beneath layers of silt and coral, protected from the ravages of time. The ocean in this light is not an empty space, but a vast, silent museum, holding in its depths the secrets of a forgotten world. These forces, cosmic impacts, volcanic eruptions, and glacial cycles, are both the great villains and the quiet heroes of our story. They are the great erasers, but they are also the great preservers. They are the reason why finding physical remains of a civilization 100 million years old is almost impossible, but they are also the very reason that the chemical and geological traces might survive. The Silurian Hypothesis in this way encourages us to see these moments of planetary violence not just as ends, but as profound turning points that may have frozen the legacy of a forgotten world in time. As we end this part of our journey, let us take a moment to honor the profound, violent, and beautiful power of our planet. It is a world of quiet creation and sudden, terrible destruction. And in that cycle, in that grand rhythmic dance, it holds its secrets. It holds the possibility that beneath a layer of iridium-rich clay, or beneath a blanket of ancient volcanic ash, or in the silent depths of a forgotten sea, lies the story of a civilization that rose, fell, and was then perfectly preserved, waiting for us to find it. Let us now shift our focus from the silent ancient archives of rock and myth to the bustling humming world of our own modern technology. For if we are to find the traces of a lost civilization, we will need more than just an open mind and a gentle curiosity. We will need tools, new kinds of eyes and ears that can see beneath the surface and hear the faintest of whispers from the past. The search for a long-lost civilization is no longer just a thought experiment. It is a quest that is being made possible by the quiet, steady march of scientific innovation. Imagine we are archaeologists, but instead of using a trowel and a brush, we are equipped with a kind of cosmic vision, a way to see through rock and soil as if they were made of glass. This is the promise of geophysical tools like ground-penetrating radar, or GPR, and LiDAR. These technologies are our new eyes, allowing us to see what lies beneath the surface without disturbing a single grain of dirt. They are the new frontier of our search, a way to map the silent archives of our planet without ever having to dig. Ground-penetrating radar works by sending pulses of radio waves into the ground. These waves travel through the soil and rock, and when they encounter something different, a buried wall, a hidden chamber, a piece of metal, or a strange, unnatural layer, they bounce back. By measuring how long it takes for the echo to return, a GPR machine can create a detailed three-dimensional map of what is hidden underground. It is like an X-ray for the Earth, and it allows us to see the ghosts of structures that have long since been buried and forgotten. For a traditional archaeologist, GPR is an invaluable tool for finding buried foundations or ancient roads, but for someone looking for a lost civilization from millions of years ago. GPR offers a new kind of hope. It could, in theory, detect the outline of a massive buried structure, a complex network of tunnels, or a pattern of materials that could not have been created by nature. The signal from a buried city might be faint, a whisper across millions of years, but GPR has the potential to hear it. And then there is LiDAR, or light detection and ranging. LiDAR is an even more powerful tool, often mounted on drones or airplanes, that uses laser beams to scan a landscape from above. The laser beams can penetrate dense forest canopies and other vegetation, and they map the ground in astonishing detail. LiDAR can reveal subtle, unnatural changes in the landscape that have been obscured by thousands of years of growth. It has already been used to great effect to find lost cities of human civilizations in places like the jungles of Central America, revealing the outlines of ancient roads, agricultural fields, and pyramids that were invisible to the naked eye. In the context of the Silurian Hypothesis, LiDAR could, in theory, reveal the fossilized footprint of a long-lost civilization's infrastructure, a massive, unnatural grid of roads that have been eroded into the landscape, a complex system of terraces that have been softened by time, or a pattern of large, inexplicable shapes that could not have been created by natural forces. These tools are powerful, but they also produce an immense amount of data, so much that a human mind could not possibly process it all. This is where artificial intelligence, or AI, comes into our story. AI and machine learning are being used to sift through the vast datasets produced by GPR and LiDAR, looking for patterns that a human might miss. And AI can be trained to recognize the subtle geometric patterns of a man-made structure, a pattern that is distinct from the chaotic, beautiful patterns of nature. An AI can look at 1,000 GPR scans of a region and, with a kind of superhuman intuition, point out the one small anomaly, the one strange echo that might be the key to unlocking a secret from a forgotten age. Beyond these geophysical tools, there are even more subtle and powerful technologies at our disposal. Spectral imaging is a technology that looks at an object using many different wavelengths of light, including infrared and ultraviolet. Everything in the world, every mineral, every plant, every piece of metal has a unique spectral signature, a kind of colorful fingerprint in the light. Spectral imaging can, in theory, be used from satellites to look for strange, unnatural patterns on the Earth's surface that are invisible to the human eye. It could detect a region of rock with an unusual combination of minerals, a silent remnant of an ancient industrial process, or a strange chemical residue from a technology we can't even imagine. It's a way to see the past through the language of light, a silent conversation between our technology and a civilization that may have died out millions of years ago. And finally, there are even more microscopic tools at our disposal. Micro-CT scanning is a technology that uses X-rays to create a detailed three-dimensional image of an object. It can be used to scan a fossil, a rock, or a mineral sample without having to break it apart. A scientist could, in theory, use a micro-CT scanner to look at a rock sample from 100 million years ago, and in a corner of that sample, find a tiny, unnatural geometric shape, a pattern of crystals that could only have been created by a machine, a minute piece of a technology that was 1,000 times smaller than a grain of sand. It is a way to look for a microghost, a silent, beautiful echo of a world that was lost to the grinding of time. These new technologies are not just tools. They are a new way of thinking about our search. They are a humble admission that our own senses are limited and that the story of our planet is told in a language that we can only understand with the help of these new powerful instruments. They are a testament to the idea that the secrets of the past are not waiting to be found, but rather are waiting for us to develop the tools to see them. They are a reminder that the mysteries of our planet are not just in the ancient myths and the great stone monuments, but in the silent, invisible spaces that lie just beneath our feet. The Silurian Hypothesis is a whisper that has found a listener in the world of modern science. It is a question that for a long time could only be answered with quiet contemplation. But now, with the advent of these new technologies, we are on the verge of being able to answer it with a different kind of quiet. A quiet of numbers and data, a quiet of laser light and radio waves. We are on the verge of being able to see the Earth not as a static backdrop to our own story, but as a living, breathing archive, holding in its silent depths the stories of all who have come before. So let us take a moment to honor the quiet, persistent work of science. It is the work of a detective, but a detective with new and powerful tools. A detective who is willing to look at the world with new eyes and to listen to its silent whispers with a new set of ears. It is the work of a dreamer who has the tools to make his dreams real. It is the work of a human, but a human who is beginning to learn the language of the Earth, a language that is written in rock and soil and isotopes, and light, a language that has been waiting for us to hear it for millions of years. Let us now allow our minds to float free from the solid ground of rock and radar and journey into a realm of pure speculation, guided only by the quiet logic of our inquiry. If a civilization did exist long ago, what would it have left behind? We've considered the chemical ghosts and the buried structures, but what about the invisible, the intangible? What about the silent hum of their machines, the faint echo of their power, and the buried secrets of their data? What kind of legacy would a technological world leave behind in the very fabric of the planet itself? This is where our journey becomes a kind of gentle ghost story, a search for the echoes of an ancient energy and communication network that might have been woven into the Earth itself. We're not looking for a fossilized power plant. We're looking for the subtle, lingering signature of its presence. We are looking for the ghost of a technological hum that has long since fallen silent. The first clue we might look for is an electromagnetic anomaly. Our planet has a natural magnetic field, a great invisible shield that protects us from the sun's radiation. It is a field that has its own gentle rhythmic patterns. But what if in a specific location there was a strange, unnatural disruption in that field? A magnetic hotspot that doesn't align with the natural geology of the area. A repeating rhythmic fluctuation that seems out of place. An ancient civilization with its power grids, its communication systems, and its energy-intensive technologies would have left behind a kind of electromagnetic scar on the planet. Even after millions of years, as the physical wires and machines decayed, the memory of that scar might linger preserved in the very iron particles of the rock, a permanent but silent record of a technological presence. Imagine a team of scientists with a magnetometer, a device that can measure the Earth's magnetic field with incredible precision. They fly over a vast, seemingly empty desert, and the magnetometer registers a strange, repeating pattern, a grid of magnetic anomalies that run for miles. A natural geological process would create chaotic, unpredictable magnetic fields. But a grid, a pattern, a repeating structure that would be a powerful clue, a silent mathematical scream from a forgotten age. It would suggest that beneath the surface there lies the fossil of a power grid or a communication network, a vast invisible web of technology that once hummed with life and energy. And what of gravity? Everything with mass exerts a gravitational pull, and that pull can be measured with sensitive instruments called gravimeters. When we measure the gravity in a specific area, we expect it to be consistent, a predictable pull that is determined by the density of the rock beneath our feet. But what if in a specific area, a gravimeter registered a sudden massive spike or dip in the gravitational pull? It would suggest that beneath the surface there is something unusually dense or something unusually hollow. A massive buried machine made of an exotic metal or a series of vast hollowed-out chambers would both create a powerful and inexplicable change in the local gravity. This could be the sign of a massive energy facility, an underground city, or a technological complex of unimaginable scale. The gravitational echo of a civilization, a silent, heavy presence that continues to pull on the very fabric of our reality, even after millions of years. The true magic happens when these clues overlap. When an electromagnetic anomaly is found in the exact same location as a strange gravitational shift, and when both of these are found in an area that GPR has identified as having a complex, unnatural structure beneath the ground, that is when a whisper begins to become a story. It is a moment of profound scientific intuition, a moment where a series of seemingly unrelated data points begin to form a coherent, powerful picture. It is a moment where a ghostly hum from the past begins to be heard again. But what about the truly advanced technology? The kind that might not have left behind a conventional footprint? What if a lost civilization had developed technology that was nanoscale, far too small to be seen with the naked eye? What if their communication and data storage was not in the form of wires and computers, but in the form of engineered particles of synthetic molecules, or of tiny, carefully arranged structures woven into the very rock and soil? This is where the quiet search of chemistry and geology comes back into our story. We would be looking for the fingerprints of these nanotechnologies. We would be looking for unusual isotopes, for strange geometric patterns in minerals that could not have been formed by nature, for synthetic compounds that should not exist in a rock sample from 100 million years ago. We would be looking for a kind of fossilized data, a silent chemical record of a lost knowledge. Imagine a scientist using a powerful electron microscope, looking at a thin slice of rock from a geological core. They see the beautiful, chaotic, and natural patterns of mineral crystals. But then, in a corner of the slide, they see something different. They see a perfect grid of tiny synthetic particles arranged in a way that suggests information, a kind of binary code written in the language of atoms. They would be looking at the fossil of an ancient hard drive, the silent, beautiful record of a forgotten civilization's knowledge preserved in the very fabric of the earth. The more we explore this idea, the more we realize that the evidence we're looking for is not something we can find by digging in the dirt. It is something we will find with our most powerful tools, with our most open minds, and with our most humble acknowledgement that the universe is probably far stranger than we can ever imagine. We are not just looking for a lost civilization. We are looking for a lost way of seeing the world, a lost way of being, and a lost way of understanding the universe. The journey we have been on is not a race to a conclusion. It is a quiet, contemplative walk through a beautiful and profound mystery. It is a journey that asks us to look at the world around us with new eyes, to see the mountains not as static backdrops, but as living archives. It is a journey that asks us to see the earth not as a silent stage for our own story, but as a vast living library, holding in its silent depths the stories of all who have come before. So as we settle into the quiet, let's take a moment to honor the mystery, to honor the possibility that our own civilization is not the first, but perhaps a continuation of a story that has been told and retold many times over in the vast, silent spaces of deep time. Here we are at the end of our quiet journey. We have drifted through the vastness of deep time, imagined the chemical ghosts of a forgotten industry, and marveled at the new tools that might allow us to hear a silent ancient hum. We have contemplated the great cosmic forces that both erase and preserve, and we have looked at our own myths and monuments through a new gentle lens. Now, as we bring our thoughts to rest, let's consider what this all means. What is the true profound impact of the Silurian Hypothesis on our understanding of ourselves, our place in the universe, and our future? The first and most important impact is one of humility. For centuries, we have believed that humanity is unique, a single solitary flicker of intelligence in a vast, cold universe. This belief has been at the heart of our philosophy, our religion, and our science. It has given us a sense of specialness, of being at the pinnacle of a long and singular evolutionary journey. But the Silurian Hypothesis asks us to consider a different story. It asks us to consider that we might not be the first, that our beautiful, complex civilization might be just one chapter in a much larger book, a book with many pages that have been lost, torn out, or simply forgotten. This idea does not diminish our own achievements. It places them in a grander, more humbling context. It reminds us that our story is just one small thread in a tapestry of life that stretches back billions of years. And in that grand tapestry, there may have been other threads, other patterns, other stories that we have yet to discover. This humility has profound implications for our search for extraterrestrial life. The search for life beyond Earth. The work of SETI and astrobiology has long been based on the assumption that if a civilization exists, it will be out there in the stars. We listen for radio signals, we look for signs of technology on other planets. But the Silurian Hypothesis gives us a new way to think about this search. It asks us to consider the possibility of a planetary bottleneck. It suggests that a civilization might rise and then, due to a cataclysmic event, a self-inflicted ecological disaster, or some other unknown factor, it might simply vanish, leaving behind only a chemical ghost in the geological record of its home planet. The PETM, with its sudden mysterious carbon pulse, is a perfect example of this. In this view, the universe might be full of these ghosts of civilizations that rose and fell their entire existence, recorded only in the silent rocky archives of their home worlds. We might not be listening for the signals of a living civilization, but for the echoes of a dead one. And if we find such an echo here on Earth, it might help us to recognize those echoes when we find them on distant exoplanets. The idea also has profound implications for our understanding of our own future. If a technological civilization existed on Earth millions of years ago, what happened to it? Did they destroy themselves? Did they succumb to a natural disaster? Did they simply reach a point of technological maturity and then, for some reason, fade away, leaving only a faint trace of their presence? The silent, rocky record of the past might hold a powerful warning for us. It might tell us that the path we are on of technological progress and planetary scale resource use is not a new one. It might show us that there is a limit, a planetary bottleneck, a point beyond which a civilization cannot go. The study of a lost civilization's ecological footprint, its technosignature, could be a mirror in which we see our own possible future. It could be a silent ancient lesson about the fragility of civilization and the profound, long-lasting impact of our choices on our home world. But the most beautiful and personal impact of this quiet journey is on our own sense of wonder. The world we inhabit, the world we thought we knew, is now infused with a new layer of mystery. The mountain is not just a geological formation. It is a monument to a vast unfolding story. The sea is not just an empty space. It is a silent ancient museum, holding in its depths the secrets of a forgotten age. The air we breathe, the rock we stand on, the stories we tell, all of it is now connected to a deeper, more profound narrative. The Earth is no longer a silent backdrop to our own story. It is a living archive, a breathing library, holding in its silent depths the stories of all who have come before. The Silurian Hypothesis is not a demand for proof. It is an invitation to a new kind of wonder. It is a gentle whisper that asks us to look at the world with a new set of eyes, to listen to its silent hum with a new set of ears, and to honor the mysteries that have yet to be solved. It reminds us that the greatest discoveries may not be in the form of a definitive answer, but in the form of a profound and beautiful question. It is a journey that began with a simple, humbling thought and ends with a quiet, beautiful conclusion that the Earth is probably far stranger, far more complex, and far more wonderful than we could ever imagine. And in the face of that mystery, all we can do is to simply and beautifully wonder.